This video is about scientific notation or standard form. It's a way of writing very large and very small numbers, which are particularly common in science, hence the name scientific notation. So for example, here's a very large number. That's 5 lots of a million, each million's 6 zeros, so that's 30 zeros here on the end of the number. To avoid writing out a number in that way, which is quite cumbersome, we use scientific notation. What we do is we say this is 8 multiplied by 10 30 times, because there are 30 zeros in the end of the number. So if I take 8 and I multiply it by 10 30 times, that is 10 to the power 30. That means multiply by 10 30 times, that power of 10. That number, 8 times 10 to the power 30, standard form or scientific notation. It's a short way of writing very large numbers, and it can also be used for very small numbers, as you'll see later. So that's a number 8 here. This number has to be between 1 and 10, but not 10 itself. In other words, 1 point, 2 point, 3 point, up to 9 point something. And then a power of 10. So in this case, to get the number at the start, I place the decimal point after the first non-zero digit, the 4. So it's 4 point. So it becomes 4.125. You then say, how many times do I multiply 4.125 by 10 to get back to the original number? And it's 6 times. This decimal point has to jump 6 digits to get after the 0 here, the last 0. So it's 4.125, and I multiply by 10 6 times. That means 10 to the power 6. So that means multiplying by 10 6 times, 4.125, the decimal point moves 6 places. Now when you write a number in scientific notation, you'll go straight from the first line to the last line. This is just to introduce the concept with the multiplication here by 10 6 times. So in general, scientific notation or standard form is this form: a times 10 to the power n. A is to be a number between 1 and 10, but not including 10. There's no bar on the inequality here. So it's 1 point something, 2 point something, 3 point something, up to 9 point something for this first number. And it's how many times do you multiply by 10 to get this number a back to the original number. N is a whole number, 0, 1, 2, 3, or its negatives, negative 1, negative 2, negative 3. They're the set of integers. So integers are whole numbers or they're negatives, and that's the power of 10 that you have. So this is a standard form, scientific notation. So here's an example: 257,000. You put the decimal point after the first non-zero digit, 2.57. You then say, how many times would I multiply by 10 to turn 2.57 back to the original number, 257,000? And it has to jump 1, 2, 3, 4, 5 places. So 5 times you've got to multiply by 10, hence 10 to the power 5. So that's a normal number, 257,000. That's the number in scientific notation, 2.57 times 10 to the power 5. Here's 4,136, so 4 point something. How many times do you multiply by 10 to turn 4.136 back into 4,136? So you just count the places, 1, 2, 3, and it's 10 to the power 3. There's 72, 7 point. And then how many times do you multiply 7.2 by 10 to get to 72 again? And it's 1 place, so it's 10 to the power 1. 7.2 times 10 to the power 1. That's a normal number put into scientific notation. Same process to take a number that's in scientific notation back to a normal number. 2.57 times 10 to the power 5 means take 2.57 and multiply it by 10 5 times. So the point shifts 5 places. When you run out of digits, you put zeros in, and that gives you the original number, 257,000. So that's scientific notation changed to a normal number. Exactly the same process as previously. That was putting it into scientific notation. It's the same process taking it out. So here's 4.136, multiply it by 10 3 times, point shifts 3 places, 4136. 7.2 times 10 to the power 1, point shifts 1 place, 72. So exactly the same process to take a number out of scientific notation as to put it into scientific notation. So that's very large numbers. For very small numbers, you need to establish a result here. So this is a sequence where to move from one term to the next, you divide by 10. So it's 1,000, divide by 10 is 100, divide by 10 is 10, divide that by 10, you get 1. Divide 1 by 10, you get a tenth. Divide that by 10, you get a 100th. Divide that by 10, you get a 1,000th. So 1,000 can be written as 10 times 10 times 10. That's 10 to the power 3. 100 can be written as 10 times 10, 10 to the power 2. 10 is just 10 in power 1. So when you divide by 10, the power of 10 goes down 1 digit each time, 3 to 2 to 1. So we're going to divide by 10, we expect 10 to the power 0, and then divide by 10 again, 10 to the power negative 1, 10 to the power negative 2, and so on. So simply, as you divide by 10, the power of 10 goes down, 3, 2, 1, 0, goes down 1 to negative 1, down 1 to negative 2, and so on. So these are powers of 10. 1,000th is 10 to the power negative 3. But equally, if you want 1,000th of something, you would divide by 1,000. If you want 100th of something, you would divide by 100. You want 10th of something, you would divide by 10. So these are also equivalent to division by 10, division by 100, division by 1,000. Dividing by 1,000, 1,000 is 10 to the power 3. So that can be written dividing 10 by 10 to the power 3. Dividing by 100 is dividing by 10 to the power 2, and dividing by 10 is dividing by 10 to the power 1. You look at the bits in blue. 10 to the power negative 1 is the same as dividing by 10 to the power positive 1. 10 to the power negative 2 is the same as dividing by 10 to the power positive 2. And 10 to the power negative 3 is dividing by 10 to the power positive 3. In other words, a negative power is the same as division. So that's the general result. If you want to divide by 10 to the power n, it's the same as multiplying by 10 to the power negative n. In other words, a negative power, negative n, is the same as a division. So we're going to use that to introduce scientific notation for very small numbers. So here's a very small number. It's got 0 point, and then it's got, in groups of 3, 30 digits. 10 lots of 3 digits, including the 008 here. So that is the same as 8 divided by 10 30 times. You jump 29 zeros, and then this 8 here gets jumped as well, so that's the 30th digit, the 8. So to get the decimal point to move from here to after the 8, the decimal point has to move 30 places. In other words, you divide by 10 30 times. So if you divide by 10 30 times, division by 10 to the power 30 using that result is the same as multiplying by the negative power. In other words, that. Division by 10 to the power positive 30 is the same as multiplying by 10 to the power negative 30. So this negative 30 here, that power is the same as dividing by 10 30 times. Now you go from the first line to the last line when you're writing scientific notation. So you don't need the bits in between, that was just to introduce it. Here's another example doing the same thing. If I want to shift that decimal point from where it is to after the 4 here, so it's 4.125, I have to divide by 10 6 times, because this decimal point has to jump 6 places to get there. So that's division by 10 to the power 6 divided by 10 to the power 6 is the same as multiplying by 10 to the power negative 6. Again, you would go from the first line to the last line. So in principle, it's simply a negative power is equivalent to a division by 10, and you do the same process before. You put the decimal point after the first non-zero digit, 4.125. You count the places the point moves, but it's a negative power. So here's an example. The decimal point has to move from where it is to after the 2 here, so it's 2.57. You count how many places the decimal point shifted, and it shifted 1, 2, 3, 4, 5 places. There are 4 zeros here, but it's got to jump that 2 as well. That's the 5th place. So it's a power negative 5, not positive 5, but negative 5, because you're dividing 2.57 by 10 5 times. Divide 2.57 by 10 5 times, you'll get this original number. So place the decimal point after the first non-zero digit. That's 4.136. Count the places the decimal point moves from being 4.136 to being 0.004136. There it is there. There's a jump of 3 places between them. So it's power negative 3. So if the number starts at 0 point something, it's going to be a negative power. And there's 0.72. Shift the decimal point to be after the first non-zero digit. That's the 7. So it's 7.2. The point shifted 1 place. Power negative 1. So that's very small numbers. They start at 0 point something. It's the same process. Put the decimal point after the first non-zero digit and count the number of places the point would move. But remember, it's a negative power for very small numbers, because this is equivalent to dividing by 10. 2.57 gets divided by 10 5 times to get back to that original number. So that's putting numbers into scientific notation. Same process for taking them out. So there's a number in scientific notation. You simply shift the point 5 places. You're making the number smaller. A negative power means you're dividing by 10 5 times. So you shift the point 5 places, making the number smaller. So notice 5 places, and that's 4 zeros. It had to jump the 2 and then 4 zeros. So that's the 5 places, and that gives you the original number. So it's scientific notation, back to normal number. Exactly the same process as putting a number into scientific notation. So the point shifts 3 places here to make the number smaller. Jumps to 4 and then 2 zeros. That's it, shifted 3 places. So there it is. And here 7.2 times 10 to the power negative 1. Shift the point 1 place. There it is, shifting 1 place, making the number smaller. So it's 0.72. So a negative power is going to start at 0 point something. So that's putting numbers into scientific notation and taking them out of scientific notation. Now, there'll be worksheets available if you click the link in the description. Now, the worksheet here has a part where it's putting numbers into and out of scientific notation. But after that comes calculations, and that's the main bit of scientific notation we're after, how to enter it in the calculator and carry out calculations. So that will come in the next video. This video is just being the basics of putting numbers into scientific notation, taking them out of scientific notation. There is a set of notes also if you click the link in the description. It has notes on all the number work. It'll include significant figures and rounding, which was in a previous video, and we'll come into the next video on scientific notation. So we've put numbers into scientific notation and taken them out. But the main part of the work, which will be the next video, is using the calculator to carry out calculations with scientific notation. Hope you found this video useful. Thank you.